Welcome back. The next question, just see here. The boiling point of 0.1 m potassium ferrocyanide is expected to be. How to solve this? See, boiling point from calculation, we can do it using elevation in boiling point equation. What is the equation there? Elevation in boiling point. Delta TB is equal to 1000 into KB into W2 by M2 into W1. Remember, this 0.1 should be the small m, molar solution, not molar solution. And one more thing, remember, this potassium ferrocyanide, where it is dissolved, is not given. So you have to take it as it is solvent as water only. We cannot take a solvent as any other. And for the water, the whatever the value of Kf is constant also. Okay. So whether they mention it or not, you should know that Kf value also. And for the water, Kf value is 0.52. Don't start saying, sir, they did not give the Kf value, so I could not solve that problem. Okay. Now see, I don't have a W2 by M2 value, etc. I have already this molar value. So I can have this one as delta TB is equal to KB into M also. And remember, this is not Kf value, this is a KB value 0.52. Kf value is 1.86 for water. So molality is 0.1, 0.52 into 0.1 is equal to 0.052. This gives the delta TB value. Then I'm not saying that this is correct one. Delta TB is equal to T minus T naught. So 0.052 is equal to T minus 100. So T is equal to 100.0 0, 5, 2. This calculation usually the student make, but this whole calculation is wrong. Why it is wrong? CO, this is a dissociated molecule, so there will be 5 ions. And remember, this delta TB, delta TF, etc. are colligative property which depends upon the number of solute particles. In this calculation, I took that potassium ferrocyanide as a 1 particle, but actually there are 5 particles. So what I should have done is, for this delta TB is equal to KB into M into I should have done, which I did not do. So now we'll solve this one properly now. You don't do that same mistake in the exam. So delta TB is equal to I into KB into M. And again, here this is small m should be molal. Okay, so it is already said I is 5. How? 4K plus and FE CN 6 4 minus charge means total 5 ions. So 5 into what I have again? CO KB is 0.5. I already mentioned this is constant for water into zero point 0.1 is the M value. So what is the value I am going to get? This whole value is almost 0.26. Okay. Now get the T value. T value is delta TB plus T naught, which is 100. Means I am going to get the value as 100.26 degrees Celsius or 373.26 Kelvin. They may give with this value in the exam, or they may go for this value also. And this is the correct method of solving. Usually students make the mistakes. See the options there. 100.52. See what the student, sometimes what the student do is they go for 100 degrees is the boiling point of the water and 0.52 is the KB value. They add that one and this write 100.52 degrees Celsius. That's also wrong. And 100.26 is the correct one. Usually what happens in the previous manner, if we solve, we get 100 point the whatever 0, 6, etc. Then we make the nearest answer 100.10 also. That is wrong. So answer is B. See now, this question. If A contains 2% NaCl and is separated by semi-permeable membrane from B, which contains 10% NaCl, which event will occur? What was there? CO? There is a vessel in which there was a two compartment made by using some semi-permeable membrane, SPM. What is the characteristics of SPM? Allow only the solvent particle to move, not the solute particle. This compartment is A, you say. This compartment is B. So, in the A compartment, we are taking 2% NaCl solution and B compartment we are taking 10% NaCl solution. So, B compartment is hypertonic whereas A compartment is hypotonic. Among the two solutions which is having the lower osmotic pressure is the hypotonic, which has the higher osmotic pressure is the hypertonic. Now, as we keep the semi-permeable membrane here, what will happen? No? The osmosis process takes place. What is osmosis? Movement of the particle. Which particle? Solvent particle only. From the lower concentration to the higher concentration through semi-permeable membrane. Actually, through this semi-permeable membrane, only the solvent particle can move around, not the solute particle. The pores here will be bigger for the solvent particle to move, whereas smaller for solute particle to move. Solvent and the solute, always solute has bigger size, solvent has a smaller size. You see, 2% that is the lesser concentration. So from this A to B, the water molecule start moving. Remember, not NaCl is moving, only the water is moving. While going for the answer also, just remember, don't get confused. See, what are the options given out there? Just see there. NaCl will flow from A to B. Students get confused sometimes because they will not read the full answer. They see there A to B. They may take this answer. But this is not the answer actually. NaCl will move from B to A. Anyway, you can neglect now. Water will flow from A to B. Exactly, this is the answer. Okay. So answer is C, where water will move from A to B. Which has the maximum osmotic pressure at a temperature T Kelvin? We'll see the options over there. 150 ml of 1 molar urea solution, 210 ml of 1 molar glucose solution, mixture of 150 ml of 1 molar urea solution and 210 ml of 1 molar glucose solution. See, what do we have? Osmotic pressure. Pi is equal to CRT. That is the equation. Okay. So here see 1 molar concentration. There is the concentration. Here also 1 molar concentration means A and B are isotonic only. What is isotonic solution? Solution having the same osmotic pressure at a given temperature. But just see here, if I go for phi 1 equal to CRT, this is for the first solution, you say phi 2 is equal to C2RT. Remember, for the isotonic solution, phi 1 equal to phi 2. Left hand side equal to each other, then the right hand side also should be equal to each other. Then C1RT equal to C2RT or C1 equal to C2 will be there. So here, since the concentrations are same, A and B options are isotonic in nature. Now see here, in the C option, 1 molar urea, 1 molar glucose. Again, they are isotonic, means answer is here D. All the above are isotonic nature, means they have the same osmotic pressure. What is osmomolarity of 0.2 m KCl? See, KCl is a ionizing molecule, so it gives K plus and the Cl minus. Means there are two ions. Okay, so what do we have the equation? Pi is equal to I into CRT. Okay, so what do you have here? For I is equal to 2 into, we have the concentration as 0.2. So I have 0.4 osmomole. Just see the options over there. 0.1 osmol, 0.2, 0.3, 0.4. Which is the option? D is the options over there. See the next question there. The 35th. Blood plasma has the following composition. All are in milli equivalent per liter. Calculate the osmotic pressure at 37 degrees Celsius. What are the ions present over there? They are given there. So, from the given data, what you have to do is now first get that milli equivalent of Na plus, calcium 2 plus, etc. Na plus, for that, what happens now? The atomic, the mass here 138 is there, no? That should be divided by 1 only, because valence is 1 only for this. Then calcium 2 plus, the valence is 2, so that 5.2 should be divided by 2. This becomes 2.6. Then K plus, again it is 4.5 only. Then Mg2 plus it is 2 divided by 2, which becomes 1, because Mg2 plus Mg is valency 2. Then Cl minus, again the valency is 1 only, so it is 105 by 1, it is 105. Then HCO3 minus also it is 25 by 1 only, so HCO3 minus, what is this? Bicarbonate ion, which is equal to 25 only. Now for the phosphate, it should be PO43 minus, not PO3. For the phosphate ion, it is 2.2 divided by 3, because charge is 3, which becomes, the value becomes 0.73. Now for the sulfate, again it is 0.5 by 2, because it's minus 2 here, which is equal to 0.25. Then protein, I'll write only P only, it is 16. Other things are of 1, right? Other OTHER, other is equal to 1. So get the total of it, then convert into milli. If I add all this, 138, 2.6, 4.5, 1, 105, 25, 0.73, 0.25, 16 and 1, total what the value I am going to get is 294 I am going to get. And convert into the milli. So it is 294 into 10 to the power minus 3. It's the milli equivalent, no? So 0.294. Now pi is equal to CRT. C I got how much? 0.294, the total milli equivalent. R is 0.0821, not 8.31. You can go for little approximation. And the temperature here is 37 degrees Celsius, which is equal to 310. And solve this. Almost, I think we'll get 7.47 ATM. You solve it yourself. This is the value. We'll see the options there. 7.47 is there, means we got the answers over there. Other options being 7.30, 7.29 and 7.40. So here don't go for approximation, because all answers are very close to each other. See here, the options are very close to each other. Now see this question. Sea water is 3.5% by mass of salt and has a density 1.04 gram per cm cube at 293 Kelvin. Thinking that the salt B is sodium chloride. Calculate the osmotic pressure of the seawater. Now see this question. What is the meaning of this 3.5% by mass of the salt means? Small m of NaCl is given out. So this is NaCl, which is equal to 3.5 gram. And mass of the solution, how much it is? M of solution is equal to 100 gram, because he said in the percentage. If the 100 gram of the solution is there, in that 3.5 gram is NaCl. Then what else is given out? Here see, density is given out. D is equal to 1.04. T is given out 293. If it is in the Kelvin scale, you have to convert it also. 293 Kelvin. Then NaCl is ionizing molecule. I value becomes 2, because one Na plus ion is there, one Cl minus ion is there. So I is 2. What they asked? Calculate the osmotic pressure. Pi you have to calculate over there. Pi is how much? So what is the formula? Pi is equal to C RT with the I. One formula. Or pi is equal to I into small m by capital M. This is the number of moles into 1 over V into RT. Why? C is number of moles in a definite volume. Because I can write it as pi is equal to I into nRT by V. I into nRT by V can write. And n is m by m. So substitute here now. Pi is equal to I is 2, m is 3.5, then capital M is 58.5 for the NaCl. Molecular mass of NaCl is 58.5 into 1 over V. I want the V value. So what will be the V value? You have to get the V value. We have this one again here, see. Density is equal to mass by volume. This is for the volume of the solution I need. Mass of the solution is given out. I want the volume of the solution. Mass is 100 gram divided by V of solution is equal to density. Density is 1.04. It is given there. So volume of the solution, I will write Vs is equal to 100 by 1.04. Okay. Now see here. This volume is what to do now? 100 by 1.04. I have to convert into the liters now. 1 liter because our concentration in the tumor. So 1000. So what I have here? This is equal to 100, the volume, divided by 1.04 into 1000. Then this numerator is multiplied by RT. R is 0.821 and the temperature is 293. You solve this. What happens now? This 1.04 and the 1000 goes to numerator and the 100 is the denominator. So it will be 2 into 3.5 into 1 into 0.0821 into 293 into 1.04 into 1000 divided by 58.5 into 100. If you solve this completely, you'll get around 29.89. Calculate it yourself. Don't use the calculator for the calculation. Without the calculator, use it. You calculate it and ATM will be that. This will be the answer. So we'll see what are the options given out there. 26.93, 29.93, 28.93, 27.93. So near option B, 29.93, you have to choose. And again, there is no large difference. So don't go for much approximations. Smaller approximation allowed, not the complete approximation you say. 8.9 is there, making 10, etc. Don't do this. Then you will get a wrong answer, or 3.5 making it 4 or 5, etc. Don't do that. Understand this? Go for the next one now. What is there? Freezing point of the solution that contains 10 gram of glucose in 100 gram of water is simple one. If you know the formula, you can calculate it. Yes, come on, tell me which formula you have to use it. Delta TF is equal to 1000 into KF into W2 by M2 into W1. So substitute. What is that? 10 gram of the glucose. W2 is here. And is a glucose. So M2 is there. What is the M2 value? Glucose. 180. And 100 gram. What is this? W1 value. What is the K value? That also given out. So go for 1000 into 1.86. And remember, KF value for water, you have to remember also. W2 is 10 divided by 180 into 100. So this two cancels here. We go for slight approximations here. This is 1 za, 100 za. So 10 1 za, 10 10 za. So I am getting the value approximately 1. Actual value is 1.03 also. And don't get confused. Sometimes in the question paper may be there. The freezing point of the solution is 1.03 degrees Celsius. Actually, this is wrong. Why no? Next calculation. This is delta TF and delta TF and the freezing point, they are related as T naught minus T, where T naught is the freezing point of the pure solvent, T is the freezing point of the solution. And remember, during the freezing point, solution freezing point is lesser, solvent freezing point is small. In the boiling point of the solution is more and the boiling point of the pure solvent is less. In the delta TB, we have to write T minus T naught. Whereas here we have to write T naught minus T. So this T naught minus T is 1.03 or 1. Okay. Approximately 1 is equal to, what is the T naught value of water? Don't say, sir, they did not give. Because it is the freezing point of the water, which is 0 degrees Celsius. So T is minus 1 or minus 1.03 degrees Celsius. So see the options there. See, they give the positive and the negative, both values. It is the D option with minus 1.03 degrees Celsius. They may give with the positive 1.03 degrees Celsius also, but that will not become the answer. See the next question there. The order of osmotic pressure of the equimolar solution. Equimolar means their concentrations are same. It may be 0.1, it may be 0.2, but all will have the same. In this type of question, what you have to do is, see which will have the higher number of ions in the solution, that is, which will have the higher I value, they will have the higher osmotic pressure. This also will be there with the, which will show the higher depression in the freezing point, higher elevation in the boiling point, which will show the higher RLVP, relative lowering of vapor pressure. In all the cases, if I value is higher and higher, then they will have the higher colligative property. Note on this properly. Higher the number of particle, that is higher the I value, higher the colligative property. In the BaCl2, I value is 3 because 1 Ba2 plus ion and 2 Cl minus ions are there. NaCl it is 2, whereas glucose is non-associated, non-dissociated, so it is 1 only. So while arranging also, the BaCl2 greater than NaCl greater than glucose. Option A. Now, sometimes what will do, no? What they do is, they will not give the equimolar solution. BaCl2 is of 0.0001 m, NaCl of 0.1 m, Then glucose is of 0.01 m. Now, don't say this is option. What you do is this concentration into I value do for everything into I value. For this also into I value and get the product. So here 0.0001 into 3 is 0.0003. This is for barium chloride. For this NaCl, zero point 0.1 into 2. This is 0.2. This is for NaCl. And this one 0.01 into 1 only. 0.01 for glucose. So in this case, NaCl greater than glucose greater than barium chloride. Only when the equimolar is there, this will be optional. See the next question there. A solution with 8.6 gram of urea in 1 liter was found to be isotonic with 5% solution of organic non-volatile solute. The molecular weight of the latter is. See, use the concept. Isotonic solution have the same concentration at a given temperature. Pi 1 equal to pi 2, that is isotonic. Therefore, C1 equal to C2. So, for urea, C1 is 8.6 divided by 60 into 1000 by 1000. If you go for the molality, okay, 1 kg is equal to C2. Mass is 5 gram divided by molar mass, I don't know, M2 into 1000 by 100, because 5% solutions over there. So M2 is equal to, what happened there? Just see here. This get cancelled here. M2 is equal to 5 into this 100 ones are 100 tens are 10 into 60 whole divided by 8.6. When I solve this, I am getting the value as 3000 by 8.6, which will be almost 3.335 or 340. This range I am going to get the answer. You calculate it. And what are the options given out there? Just see there. 348.9, 34.89 cannot be option. So leave that option. Again, here see 60 into 10 is 600 into 5. 600 into 5 is 3000 and it should be divided by 8.6, which cannot be 3489. So B and C is directly neglected. 861. Again, 3000 by 9 you make. 8.6 you approximate 9. So that also will not give 861. So without doing the further calculation, you can say that A is the option also. Just see this one now. A compound MX2 has observed and normal masses are 65.6 and abnormal are 164. See, this MX2 compound has a observed and the normal masses as 65.6 and 164. So observed mass is 65.6 and normal mass 164. Using this, what I can do is I can calculate the I value. I is normal mass divided by observed mass is equal to normal is 164, observed is 65.6. I am going to get the value as almost 2.5. So which is I value. So I value is 2.5. Now, what you need? I want to calculate the degree of ionization. What is the degree of ionization formula? Symbol? I have to calculate the alpha. What is degree of ionization? Number of moles ionized from total number of moles. And remember, MX2 is a ionizing molecule, not associating molecule. For that, alpha is equal to I minus 1 divided by n minus 1. Use write this formula in your formula list. And remember, this is only for ionized molecule, not for associated molecule. Note it properly. Like NaCl, KCl, MgCl2, potassium ferrocyanide, there only you can use this formula. Alpha is equal to I minus 1 divided by 1 n minus 1. And remember, n is the number of ions. MX2, what is the number of ions there? N is 3. Why n is equal to 3? There is one M2 plus ion and there are two X minus ion. So number of ions are 3. So use that formula in the formula. Alpha is equal to 2.5 minus 1 divided by 2 minus 1 or 3 minus 1. 3 minus 1. So it is 1.5 divided by 2, which is equal to 0.75. We'll see the options now. First one is 75%, 85%, 65%, 25%. I don't have any value with 0.75. Tell me the answer now. See, this 0.75 will be there from the 1. So here they did not give with that. They are given with the percentage. So whatever 0.75 you got, no, for that multiply by 100, which give the percentage. See, in 1 mark question, you got 0.75 mark, you see. If you're asked, what is the percentage of mark you got? Again, you cannot write 0.75. You have to say that I got 75% marks. The same concept here. Okay. So answer is 75%. And remember, alpha is equal to I minus 1 divided by n minus 1 formula is there only for the ionized molecule, not for associated molecule like whatever benzoic acid in benzene, where dimerization takes place due to the hydrogen bond formations. Thank you. Read well. Practice these questions. It is good for you people only. Remember this. Thank you once again.